Okay, guys, I'm going to do some corrections for you over the test. Okay, make sure you follow along. You're taking your corrections so you can get those points back on your test if you need them. Okay, so let's start with page 1. Number 1. Sorry, guys. Jack tossed a coin 3 times. So if he tosses it 3 times, that means there should be 3 branches on the tree. Okay. Which tree diagram shows all the possible outcomes of the coin landing heads up or tails up? So we know on a coin, there's 2 outcomes, heads or tails. So the first time he's going to get a heads or a tail. So there should be heads started and a tail started. So if this says heads and this says heads, then I know it's not that one. This one just starts with tails and there's no heads, so it's not going to be that one either. Let's see, heads and tails, good. And then it goes heads, tails, heads, tails, heads, tails, awesome. Tails, heads, tails, heads, tails, heads, tails, okay? So that's good. So it's C, because D only has 1 as well. Okay. A study of a population of 1,200 frogs, so it's a total, revealed that 12 out of every 180 frogs in the population have spots on their back. Okay. So this is going to be a prediction. Based on the results of the study, how many frogs in the population do not have spots on their back? Okay. This is a prediction. So I have to set up my proportion. Okay. If your answer totals aren't fractions, that means we got to do the prediction. Okay. So I know 12 out of every 180 frogs. So this is a number of frogs, and this is spots. Okay. And then total frogs is 1,200. Okay, so I'm going to look for how many have spots and then just do subtraction, okay? Because then my numbers won't be too big. If I do 180 minus 12, I'm going to have 168, and that's a big number to multiply by 1,200. So I'm going to start with how many do have it. 1,200 times 12, because we cross multiply and then divide. 0, 0, 2 times 2 is 4, 2 times 1 is 2, 0 placeholder, 0, 0, 1 times 2 is 2, times 1 is 1. 0, 0, 4, 4, 1. Okay, and then I divide by 180. 180 goes into 14,400. Okay, it can't go into 1, 4, 114, 144, so it's going to go into 1,440. So let's try 8 first. So I'm going to try 8 first because all of these start with an 8, a 1, or a 1. So I'm going to start with an 8 first. Okay. 0, 8 times 8 is 64. 8 times 1 is 8, plus 6 is 14. See? 8. 1, 4, 4, 0. And there's 0 there, so there's going to be 0 there. Okay? Oops, sorry. Not that one. It's not that one because that's how many have spots. Have spots. Sorry. Okay? And I want to know how many do not have spots. So I'm going to take that 1,200 total and subtract 80. 0, borrow, 2, 1, 1. So 1,120 don't have spots. Okay, so it's J. Okay. Number 3, the spinner has 8 congruent sections. 8 congruent sections. Okay, the spinner is spun 120 times. What is a reasonable prediction for the number of times the spinner will land on an even number? Okay, so it's a prediction, so we've got to set up a proportion. Okay, so I know there's 8 sections. Okay, so this is my total down here, and this is my even up here. Okay, total, there's 8 total sections here, and it's been spun a total of 120 times. Okay, so now let's see how many numbers are even up here. So numbers that are even end in 0, 2, 4, 6, or 8. Okay, or are those numbers? Not 1, not 9, not 5, not 3, 2, 16, and 8. Okay, so I'm going to put 3 over 8 here, and that's my x. I'm going to multiply 120 times 3. 0, 6, 3, and then divide that by 8. 8 goes into 36 4 times, 32, 40, 45 times. So it would be B, which is 45. Okay. The table shows the types of movies and the number of DVDs rented by customers at a store in one day. Okay. Based on the data in the table, what is the probability that a random customer will not rent a drama? Okay. So first of all, I need to find the total. Okay. Because the total is always what goes on the bottom. Total is down here. Okay. And then the number I'm looking for. So this would be not drama on top because that's what I'm looking for. Okay, so let's get our total. 25 plus 36 plus 52 plus 12. 5 plus 6 is 11, plus 2 is 13, plus 2 is 15. 2 plus 1 is 3, 6, 11, 12. Okay, so a total of 125 movies. Okay, and then we need to know how many are not drama. So I'm going to do 125, subtract my drama number, 25, which is 100. So there's 100 out of 125. Okay, so let's reduce that. 100 over 125. You guys can start with smaller numbers if you need. 5, things like that. But I know 25 goes into both of them. Because I'm thinking about quarters. There's 4 quarters in a dollar, which is 100. And then 125 would be one more quarter, so that would be 5. So my answer would be 4/5 because the probability of renting a drama is 1/5. So you could have done that as well. My drama is 25, so I could have done 25 over 125. Same thing. 5 by 25, that's 1 quarter, that's 5 quarters. Okay, make sense? Awesome. Okay, number 5, a store manager receives a delivery of 2 boxes of light bulbs, 2 boxes of light bulbs, okay? Each box contains 25 light bulbs, okay? So if every one box has 25 light bulbs, then 2 boxes would have 50 because 25 plus 25 is 50. Just like you're counting quarters. 2 quarters is 50 cents. The store manager tests all light bulbs and finds that 2 of them are defective. Based on these results, what can the store manager predict about the delivery of light bulbs? So when he got 2 boxes, there were 2 broken light bulbs. Okay? So from there, I can assume that because 2 have 2, then each box is going to have 1 defective light bulb. So that means 3 would have 3 broken, 4 would have 4 broken, and so on. Okay? So a delivery of 3 boxes will contain 3 more defective light bulbs than a delivery of 2 boxes. Okay? So 3 boxes we determined had 3 broken light bulbs, right? That's not 3 more than 2. It's only 1 more than 2. So it's not that one. A delivery of 4 boxes will contain 2 more defective light bulbs than a delivery of 2 boxes. So there's 4 broken in 4, and there's 2 in 2. So 2 plus 2 would be 4. So that is correct. Okay. Felix has a bucket of golf balls. The table shows the number of golf balls of each color in the bucket. Felix selects a golf ball at random. Based on the information in the table, which statement is true? So let's look at this. Which statement is true? So I need to add all of these. I need to find the probability of getting all these first. 18, 11, 8, 4, 16, 21, 2, 3, 4, 41, 7, 16, 17. Yeah. So 18 out of 41, 8 out of 41, 11 out of 41, and 4 out of 41. Okay, the golf ball is more likely to be green than all the others combined. 18. If I did 8 plus 11 plus 4, that's more than 18. So that's not true. If it's more likely to be green, green would be bigger than all of these numbers added together. And I know that's true because 8 plus 11 is already 19, and that's already bigger than green. The golf ball is equally likely to be pink, white, orange, or green. Equally likely. If it was equally likely, all of these would be the same. So it's not that one either. The golf ball is 2 times as likely to be orange as it is to be pink. So let's look at orange and pink. Okay. If I do 4 times 2, I get 8, which is orange. So that would be true. Okay. Number 7. Letitia has 2 bouquets of flowers. Each bouquet contains 13 daisies. So each one contains 13 daisies. Okay, bouquet S contains 30 flowers. Bouquet T contains 13 flowers. Okay, so to find the probability of daisies being in it, I would do 13 over 30 because that's the total here. And each one has 13. And then we're going to do 13 over 13 there as well, which this equals 1, right? So no matter what, this bouquet of flowers has all daisies in it. So no matter what, I will always pick a daisy from bouquet T. The probability of randomly selecting a daisy from bouquet S is less than the probability of randomly selecting a daisy from bouquet T. Is that true? Yes, because this is still a fraction and this is a whole number now. So 1 is bigger than any fraction that's smaller than it. So it's going to be A. And let's see, you might have wanted to choose this one, but it says bouquet S is 1, but bouquet T is the one that's 1. So it's why that's not 1. Mildred has a bag of coins. The bag contains 10 dimes, 5 nickels, and 1 penny. She will randomly select 2 coins from the bag one at a time without replacement. So without replacement. So that means when I'm working on this, I'm going to find the total number of coins and then subtract 1 from here and do that. So 10 plus 5 is 15, plus 1 is 16, and then this one would end up being 15. Okay. What is the probability that she will select a dime and then a penny? So I'm going to put a dime here. There are 10 dimes, so I'm going to put 10 here. And then there's only 1 penny, so I'm going to put 1 there. Okay. 10 times 1 is 10. And then 16 times 15. 30, 5, 8, 6, 1, 0, 14, 240. So it'll be 240. Okay. And then I can divide both of these by 10. Because if they both end in 0, you can divide both of them by 10. 10 divided by 10 is 1. 240 divided by 10 is 24. So my answer is 1 out of 24. Okay. Gabriel has these cans of soup in his kitchen cabinet. 2 cans of tomato, 3 cans of chicken, 2 cans of cheese, 2 cans of potato, 1 can of beef. Gabriel will randomly choose 1 can. So he's just choosing 1 can. Then he will put it back. So put it back means he's replacing it. Replace. And randomly choose another can. What is the probability that he will choose a can of tomato, 2, and then a can of cheese, 2. Okay, so if he replaces it, that means my total is going to stay the same. So let's add these up. 2 plus 3 is 5, plus 2 is 7, plus 2 is 9, plus 1 is 10. All right, guys. 2 times 2 is 4, 10 times 10 is 100. I can divide these both by 4. 4 divided by 4 is 1. 100 divided by 4 is 25 because there's 4 quarters in a dollar, right? 4 quarters in a dollar. So my answer is 1 out of 25, which is C. Rachel, last one, guys. Rachel is setting up tables for a party. 4 of the tables have red tablecloths. 8 are covered with white tablecloths. Guests will be randomly seated at the tables when they arrive. Each table can seat 8 guests. What is the probability that the first guest to arrive will be seated at a table with a red tablecloth? So we're talking about tables here, so I don't need to know how many guests are at a table. Okay. That's something we could use in the future with more complicated probability, but right now that's not what we need. So I know my total tables, 8 plus 4 is 12. Okay, and then I want red tables. So red tables, there's 4 of them. And then I reduce divide by 4, and I get 1 out of 3, which is G. Okay, guys, and that's all there is. I hope you guys have a great day. Let me know if you have any questions. Bye.